Welcome to Know What You Are Investing podcast. We decode the world's top companies, what they do, how they grow, why it matters. In this episode, we dive into the highlights. From NVIDIA CEO Jensen Huang's keynote at COMPUTEX 2025, where he unveiled how NVIDIA is shaping the next industrial revolution, the era of AI factories.
Welcome to the Deep Dive.
Great to be here.
Today, we're taking a really fascinating look into the future of computing. Specifically, Jensen Huang's keynote at COMPUTEX 2025.
Yes, the whole AI factories concept.
Exactly, that's the central theme. And, NVIDIA and Taiwan, they go way back. COMPUTEX is kind of the heart of it all, isn't it?
It really is. The whole ecosystem is there. So his keynote wasn't just like a minor update. It felt pretty foundational.
Right. So our mission for this deep dive is to really unpack that vision. What are these AI factories? What did he announce? What does it all mean? We'll be drawing straight from the keynote itself.
Sounds good. He started off looking back a bit, didn't he, on NVIDIA's own journey?
He did. From just chips to being an essential infrastructure company, and now his term, an AI infrastructure company.
That framing is interesting. It really changes how you think about what they do.
Yeah, and he pushed that further with analogies. He compared AI infrastructure to big historical shifts, like electricity or the internet.
That's a bold comparison, suggesting AI is becoming that fundamental, that essential.
It really makes you stop and think about the scale, right? What are your thoughts on that analogy? Is it fitting?
I think it's powerful. I mean, electricity, the internet, they weren't just technologies. They became utilities, platforms for everything else. So positioning AI infrastructure that way, it implies it's this new layer that everything else will be built on top of. You start thinking about access, regulation, entirely new industries maybe.
That's a great angle, and it leads right into the main idea. AI factories. He specifically said AI data centers is, well, kind of the wrong way to describe them.
Yeah, he was quite emphatic. Not just storage and processing, but production centers.
Production centers. And what are they producing?
Tokens. He said they consume energy and produce something incredibly valuable, tokens. This reframing is key, I think.
How so? What's the implication of focusing on tokens?
Well, it shifts the value proposition, doesn't it? It's not just about compute cycles anymore. It's about generating this digital output. Like a real factory makes goods. These AI factories make tokens. It could even lead to, new economic models around that output.
Interesting. Like valuing the AI's product, not just its processing time.
Yeah.
He also talked about the market size exploding. Right?
Yeah. From, what was it, a $300 million chip business way back to a $1 trillion data center market. And now he's talking multi-trillion dollars for AI factories and infrastructure.
It's just staggering growth. What's driving that kind of projection? It can't just be faster chips.
No, it's way beyond that. It's the sheer demand for AI everywhere. Plus, the models themselves are getting incredibly complex, needing way more power.
Right.
And we're seeing totally new AI applications popping up that just weren't possible before. So it's about building this whole new ecosystem, really. Okay,
so with that huge scale in mind, let's maybe dig into the tech that actually makes these AI factories possible. What's under the hood?
Right, the foundations. He stressed it's accelerated computing and AI, but crucially, the fusion of the two. And a huge part of that fusion comes down to their libraries, CDX libraries specifically.
The libraries. He made that comment, didn't he? NVIDIA is the only technology company in the world that talks about libraries nonstop. Why so central?
Well, think of them as like super optimized building blocks, pre-written code for common but really complex tasks in AI and computing.
So developers don't have to start from scratch every time.
Exactly. It speeds things up massively, ensures performance on their hardware, and lets them accelerate very specific areas without needing deep hardware knowledge.
Okay, and he listed quite a few. I recall CUPI for numerics, Aerial for radio signals, 5G, 6G.
Yeah, Aerial for the RAN stack, the radio access network. That's enabling software-defined RAN, making mobile networks more flexible.
Gotcha. And then PARS for genomics, MONAI for medical imaging, Earth-2 for weather.
Yeah.
This was pretty long.
It really shows the breadth, doesn't it? Each library is like a deep investment in a specific domain. Take Aerial again, you see big telcos like SoftBank, T-Mobile getting involved. It's opening doors.
And there's Quantum, too, for quantum classical computing. Megatron for huge deep learning models. Dynamo QDF. KU Litho is interesting, too.
KU Litho, yeah, for computational lithography. That's super critical for actually making chips. He mentioned working closely with TSMC, ASML, synopsis there.
So these libraries aren't just about speed, they actually enable new things.
Absolutely. They unlock new markets, new possibilities, like AI running directly on 5G or 6G networks,
Yeah.
or blending quantum processing units, QPUs, with GPUs in future supercomputers. They're exploring that with CDIQ. It all builds on these specialized libraries.
It's like they're providing the specialized tools for innovation across the board.
Okay, let's shift gears slightly. He also talked about how AI itself is evolving.
Right. He laid out a kind of progression, started with perception AI seeing patterns, then generative AI creating stuff like ChatGPT. But the next steps, he said, are agentic AI and physical AI. Agentic AI. He called it a robot in a digital form, able to understand, think, act. That phrase, digital workers, popped up, and even HR for digital workers.
Yeah, that was provocative, wasn't it?
It was. What are the implications there? What could these digital workers actually do?
Well, if you imagine AI agents that can really reason, use tools, maybe even collaborate, the impact could be huge.
Yeah.
Think automated customer service that actually solves complex problems, or digital assistants managing really intricate workflows.
And the HR part suggests managing them like actual resources.
Kind of. Optimizing them, deploying them. It's a whole new management layer, potentially.
Yeah.
And then there's physical AI.
Physical AI understanding the real world. He used the self-driving car training example, generating synthetic videos.
Right, where the AI needs to grasp concepts like object permanence, how things move and interact in physical space.
Why is that physical grounding so important?
Well, for AI to be truly useful outside of just digital tasks, it needs that understanding. Self-driving cars, warehouse robots, you name it. They have to safely and effectively navigate the real world. Physics matters.
Okay, so AI is getting smarter, more capable, needing to understand the physical world, which logically needs more powerful hardware.
Exactly. Which brings us neatly to the Grace Blackwell platform.
Presented as the next big leap. He focused on inference time scaling, so making AI predictions faster, and also enabling thinking AI, more complex reasoning.
And a key point was how it scales. Scaling up, making single systems incredibly powerful, and scaling out, connecting many systems together. He emphasized scaling up is particularly hard.
Why is scaling up so challenging but important?
You hit physical limits with single chips pretty quickly. So building these massive, tightly integrated single systems pushes those boundaries. It's crucial for the absolute biggest AI models. He said Blackwell HGX systems are in full production now.
And the GB300 upgrade is coming, with more inference power, memory, networking.
Yep. And he gave that really striking comparison.
The one about a single GB300 node.
Yeah, having performance comparable to the entire Sierra supercomputer from, 2018? Just 6 years ago.
That's incredible. The pace is just relentless.
It really is. But you can't connect all that power without incredibly fast interconnects, which led him to talk about Unveiling.
Unveiling, the world's fastest switch, he called it.
Right. It's the backbone inside these AI factories, connecting thousands of GPUs in a rack. He mentioned miles of cable, bandwidth higher than peak internet traffic. It basically lets all the GPUs in a rack talk to each other almost instantly.
So the whole rack acts like one giant disaggregated computer.
Essentially, yeah. A single motherboard with GPUs spread out but acting as one. We're seeing this deployed already. CoreWeave, Oracle Cloud, and that XAI Colossus factory, Stargate, they're using this architecture.
Building these things must be unbelievably complex. He touched on the manufacturing side, too.
He did. He walked through the process, highlighting all the partners in Taiwan. TSMC making the silicon, KYEC testing, Foxconn assembling, Cooler Master handling thermals. Just a huge ecosystem effort.
It really underscores Taiwan's role. And speaking of commitment, there was that big announcement about building an AI supercomputer in Taiwan.
Yes, a huge one. A collaboration with Foxconn, the government, and TSMC. A very strong signal of their partnership there.
Definitely. He also introduced something called NVIDIA NVLink Fusion. What's that about? It sounds like opening things up a bit.
It does seem that way. It allows non-NVIDIA components, other CPUs, specialized ASICs, to connect into that super-fast NVLink fabric.
So more flexible, maybe semi-custom AI systems?
Potentially, yeah. It fosters a more open ecosystem, allows companies to build systems optimized for specific things, using different components but still leveraging NVIDIA's interconnect. He listed partners like L-Chip, Astera Labs, Marvell, MediaTek, Fujitsu, Qualcomm. Quite a few big names showing interest.
Interesting move. Then he shifted to some actual new products aimed at different scales, DGX Spark.
Yeah, the personal AI supercomputer for developers. He compared its performance to the original DGX-1, showing how far things have come.
And DGX Station, the desk side one, Powerful enough for trillion parameter models, apparently, but plugs into a normal wall socket.
Right. The goal seems to be democratizing access to serious AI power, putting it on developers' desks, researchers' benches, and critically, he mentioned the unified programming model across all these scales, from the Spark up to the giant AI factories.
Making it easier to scale development work. This all points towards what he called AI native computing, right?
Right.
And needing to rethink enterprise IT.
Exactly, which led into the RTX Pro Enterprise and the Omniverse server, trying to bridge that gap.
How so? How do they bridge the gap between traditional IT and this new AI stuff?
Well, the Omniverse server is designed to support both. It can handle existing enterprise stuff by 86, hypervisors, Kubernetes, but also provides the high-performance networking using their CX8 tech needed for demanding AI agents and models like DeepSeek R1.
So enterprises can integrate AI without a complete rip and replace.
That seems to be the idea. And alongside that, he introduced the NVIDIA AI data platform featuring IQ NVIDIA AI Query.
IQ for semantic search on unstructured data, finding meaning in documents, emails, that kind of thing.
Precisely. He stressed the speed and accuracy and the integrations with big storage players like Vast Data. They showed a cool sales research agent example from Vastel, Hitachi, IBM, NetApp.
How important is tackling that unstructured data for businesses using AI?
Oh, it's massive. So much valuable enterprise information is locked up in unstructured formats. Being able to query it effectively with AI it's crucial for unlocking insights.
Makes sense. And then AI ops, a new software layer.
Yeah, for actually managing AI models once they're built, deploying, monitoring, optimizing them in an enterprise setting. Partners like CrowdStrike, Taiku, DataRobot were mentioned there. It's about operationalizing AI.
Okay, so hardware, libraries, AI evolution, enterprise integration. That brings us to the final big piece, robotics.
Right. He started with the virtual world side of things, training robots in simulation, powered by the Newton physics engine.
Developed with DeepMind and Disney Research, interestingly.
Yeah.
And it's going to be open sourced, integrated into Mujoko and Isaac Sim.
Yeah, that open sourcing is significant. It provides a really high-fidelity GPU-accelerated simulation tool for the whole robotics community, essential for training robots safely and efficiently.
And that virtual training ties into the Isaac Group platform.
It does. GR00T includes the Jetson Thor processor for the robot itself, and the Isaac GR00T N1.5 operating system, which is also open source and comes with pre-trained models.
He talked about the data problem in robotics, too. Getting enough real-world training data is hard.
Very hard, yes. And their solution involves using AI itself to amplify human demonstrations. Tools like Cosmos and GR00T Dreams to generate synthetic data and action plans.
Using AI to create data to train AI, it's kind of meta.
It is, but potentially very powerful for overcoming that data bottleneck. He painted a big picture for humanoid robotics, too, potentially addressing labor shortages, becoming a multi-trillion-dollar industry.
Wow. And Omniverse came up again here, didn't it, for digital twins?
Yes, creating virtual replicas of not just robots, but equipment, even entire factories. He showed examples from lots of Taiwanese manufacturers: Delta, WeWin, Pegatron, Foxconn, Gigabyte, Quanta, even TSMC's fabs.
Using digital twins for what exactly? Factory layout? Planning, optimization.
All of the above. Optimizing piping, planning factory flows, improving power and cooling efficiency, developing and testing robots in the virtual twin before deploying them in the real factory. He really positioned Taiwan as pioneering this software-defined manufacturing using Omniverse.
It ties everything together nicely. And the final announcement, NVIDIA Constellation, their new office in Taiwan.
In Beito-Shilin, yeah. Kind of a symbol of that deepening partnership and their long-term commitment to Taiwan being central to this AI future.
It really was a comprehensive vision he laid out, connecting all the dots.
Absolutely. From the basic tech through the evolving AI to the hardware, the enterprise applications, and finally robotics, all converging.
Okay. Well, thank you for joining us on this deep dive into Jensen Huang's COMPUTEX keynote and this whole concept of AI factories.
My pleasure. Lots to process.
Definitely. The key takeaways feel pretty significant, don't they? This fundamental shift to AI infrastructure.
Powered by accelerated computing and those crucial libraries.
Right. And AI evolving towards agentic and physical capabilities.
Enabled by hardware like Grace Blackwell.
And then seeing it push into the enterprise and robotics. It's a lot.
It really is. This convergence of the physical and digital driven by these AI factories. It's going to reshape, well, pretty much everything, isn't it? Industries, daily life.
Profound implications.
Yeah.
It leaves you wondering exactly how it will all unfold. Something to keep watching, for sure.
No doubt. And amazing to see COMPUTEX in Taiwan right at the epicenter of it all.
Indeed. Well, until our next deep dive, keep exploring.
Thanks for your listening Know What You Are Investing podcast. Decode the world's top companies. What they do. How they grow. Why it matters.